1912, a German meteorologist named Alfred Wegener proposed a theory about how the Earth's landmasses formed. He suggested that the great continents of the Earth had once formed a single landmass called Pangaea, which had broken up and drifted apart over time. He called this process continental drift, and it went against all conventional thinking of the time, making him very unpopular amongst his peers. It's a shame because he was absolutely right. But it would take the work of a young cartographer called Marie Tharp to help turn the tide of opposition, leading to one of the greatest paradigm shifts in the earth sciences, and it all began at the bottom of the ocean. Marie's father worked for the Department of Agriculture, and from a young age she'd join him on his work trips as he travelled around the country collecting samples for soil survey maps. These early experiences were formative in developing Marie's interest in geology, and after gaining a master's degree in the subject, she landed a position at Columbia University in 1947. Here, she worked as an assistant to Bruce Heason, a geology graduate who's collecting thousands of depth measurements across the Atlantic Ocean. During expeditions, Heason and his team used echo sounding to collect depth data, which involved sending out high-frequency sounds or pings and recording the time delay of the returning echo. The data could then be plotted to build a profile of the terrain below. Unfortunately for Tharp, women were prohibited from joining these early expeditions because of a fear that they'd bring bad luck at sea. Instead, she remained behind at the university to process the data, converting endless rows of depth measurements into detailed profiles of the ocean floor. Conventional thinking had once believed that the ocean floors were flat, featureless plains, but Tharp's maps were beginning to tell an entirely different story. Her profiles reveal the existence of a complex geography of crevices and valleys, but perhaps most startling was the emergence of a long V-shaped cleft that ran through each of her profiles. These so-called rift valleys offered support for Wegener's continental drift theory. If two landmasses were moving apart, they'd split the ocean floor in two, tearing a scar in the landscape and forming a valley below. Was this evidence for the controversial theory? Tharp believed so, but Heason was sceptical, dismissing many of her suggestions as girl talk. Nevertheless, Tharp was convinced by her findings and later produced a more detailed physiographic map to further support her case. At the same time, another graduate student, Howard Foster, was plotting the epicenters of earthquakes in the same region of the Atlantic. Tharp noticed that they occurred at the same location as her proposed valley, and as they expanded to other areas, they found something interesting. Where there were mid-ocean ridges, there were also earthquakes. So it seemed as though these two were related. At this point, even the sceptical Heason could no longer deny what they were looking at. A pattern of scars that spanned the Earth's oceans, permanent wounds torn into existence through the process of continental drift. The findings were finally reported in 1957, but opposition from the scientific community was still fierce. Renowned explorer Jacques Cousteau was so sure they were wrong, he chartered an expedition to film the ocean's floor to settle the score once and for all. But the footage he brought back did the opposite. It showed the deep valley, it showed how it split the mid-Atlantic ridge in half, and it showed that Tharp's maps were right all along. It was exactly where she'd plotted it. As the evidence mounted, a paradigm shift in the earth sciences was inevitable. Tharp's steadfast determination had paved the way for Wegener's continental drift theory to gain traction, and as the tide of opposition waned, it gave birth to our modern understanding of plate tectonics, and secured Tharp's position as one of the most outstanding cartographers of the 20th century.